Yes, the recording. Hang on, I gotta stay. So, let's go through these assessments one by one. Dimensional analysis, I heard it was hard, I heard it was fun. Great. So, that's okay. Those aren't mutually exclusive. You can be both, yes?
It was fun.
It's definitely interesting. The last question is definitely challenging. I've rewritten that one a number of times over the past because I used to just ask the question in part E in the beginning, or the question in part 5 of E in the beginning. You know, if you spill a barrel of oil on the ocean, how big a spill does it make? And students were getting completely freaked out by that because they didn't know where to start. Like, oh my God, what do you mean? And then I said, okay, let's break it down. Let's talk about what happens when you spill oil into liquid. How many of you guys? I was talking to Kelly about this. When your car's parked on a street and it rains the night before, or if water gets under your car and your car drips oil, you've noticed what happens. Yes, even a couple drips of oil will spread out surprisingly. You know, like a drop of oil on water. Try it at home in like a glass, not a glass, like a pan of water. Pan of water, let it drop, and then just drop a drop of olive oil into that. And watch what happens. It's kind of staggering how one drop will do that. And that's because it spreads out one molecule thick. I mean, you have to think of oil not as this like slippery substance, which it is, but think of it as little tiny, teeny ball bearings that drop and then spread. They're all bound together via something that teaching chemistry I don't fully understand. But essentially what happens is all those little ball bearings are sitting in that drop, and when they hit, gravity pulls them down and they spread out. So that's what I asked you to calculate in that problem, is how far do they spread? Was it surprising for you?
A little bit.
A little bit, yes. How many miles? Yeah, depending on what you're routed to, somewhere between 20 and 30, 28, 22, 25, somewhere. It's ridiculous, yes? Ridiculous. And that's one barrel. One. How many of those ships, when those ships run around like the Valdez and when the BP explodes down in the Gulf of Mexico, how many barrels of oil are leaching there? More than one, yes?
4.9, wasn't it? I looked it up. 4.9 from the Gulf Horizon explosion.
4.9 what?
4.9 billion barrels.
Oh, maybe. I actually calculated, oh hell, hang on. I need you to ask me this. I based it on a flow rate per day. In 244, I actually had the kids explore it because I have a YouTube, I think I told you this, I had a YouTube video showing the leak, and you can, from that piece of information, extrapolate out and figure out how much it was. It was, well, I tell you this, the amount of oil that leaked out of BP, those of you not doing 244, if you calculate, this is depressing, but if you figure out how much oil our country uses in one day, it's 25% of that. So you got to remember, when BP exploded back in 2010, down in the Gulf of Mexico, it belched natural gas and crude for 86 days, round the clock, 86 days. Now, it wasn't always the same speed. Sometimes it got slower, sometimes it got faster. They were working on it, they failed. But that's a lot of oil, yes? But if you add up all that oil, worst case scenario, all that oil, multiply it by 4, that's how much oil this country uses in one day. Okay, one person quietly says that's disgusting. That's appalling. That's friggin' ridiculously appalling. Because everybody made a humongous deal about BP, as well they should. Because that's unnatural, it shouldn't have happened. I mean, it was a terrible accident that and people got hurt, obviously, people died on that accident. But at the same time, all that oil leaking round the clock for 86 days is a fraction of what we use in one. That just, I went to class pissed that day. I showed up, the kids were like, what the hell's wrong with you? I'm like, just sit up, shut up! Do this! And it was basically, I made them do the math in class that day, and they were pissed by the end. But mostly because I imparted it on them. But it was depressing, and surprising and depressing all at the same time. So I'm going to have you guys play with that data in your last project when you start graphing things in Excel. I have you use oil production and consumption of the United States versus other countries in the world, and just kind of seeing how we stack up in those. Natural resources is an interesting field. It's got mathematics in it, of course. How many of you guys are in that field right now? Natural resources, forestry, none of you wildland fire, anything like that? Every year I have the forestry class, the sustainable building class, Forestry 260, comes to my house, and we hippie out for like 3 hours, walk around the house, find out all the little green hippie touches I've put in. And we talk about this kind of stuff, like why you should care. Why you should care. And using mathematics, it's just hilarious. Tied to that, Carrie. Natural gas. You've heard of fracking. I'm assuming you've heard of fracking. Fracking was hailed as like the be-all and end-all of the fuel problem because now we have as much gas as we possibly could ever want. because we can frack it out of the ground. And I honestly haven't done all that much research into the process of fracking. I know it uses energy to get energy. I do know that. It's kind of like, what was the fuel that W loved? Ethanol. Ethanol. Ethanol is the future. Ethanol is the future. Ethanol is terrible. To make a gallon of ethanol, it takes more than a gallon of petroleum. So it's like, okay, I don't get that. So what they do is they subsidize the petroleum to make it seem like it's saving money. It's like this shell game. I don't know how fracking plays into that. I'm not going to discount or support fracking because I haven't done the research that I did with ethanol. But I did do research with natural gas. And I have calculated using really, really good mathematics, the same mathematics you guys are using in this class, that based on the most generous estimates of how much natural gas is left in the earth, we have 50 years left at our current usage rates. That's it. 50 years of natural gas left. This is using the most generous estimates of the quadrillion cubic feet that are left, a lot of which is in America, which is kind of cool. A lot of natural gas in this country. Wyoming's got a buttload, South Dakota's got a buttload. Buttload's a mathematical term, it's a lot. 50 years, if you look at the population growth of the world, not just the country, but the world, and assuming that they're going to keep growing at the same rate, which we're going to look at that later on, if not today, on Monday, the growth rate of America, which is fairly predictable if you look at it over time. It's pretty predictable. And then you look at current usage of natural gas. There's an intersection point. If you take a top line at that, I'm going to make up a number here, 400 quadrillion cubic feet of natural gas. I'm going to make that up. Because I forget what the actual, if anybody wants this, I'll email it to you. I have it all done up in a presentation so you can see it. It's a ceiling, basically. And if you do what's a technique called integration, remember how you guys did calculus last class with my speed, 25 miles an hour? That's called differentiation. Undoing differentiation is called integration. So if you had my average speed for the whole trip, Will was 13 something miles an hour, I believe it was, right? And you knew how long I did that trip for, you could reverse differentiation to figure out how many feet I covered. So that's what calculus is all about. In grand terms, how fast is something moving? How far did it go? And that's called differentiation, Math 251, and integration, Math 252. I used a little bit of integration, Math 252, and I figured out at what point does the usage curve hit that 400 quadrillion cubic feet. 50 years. And everybody that's told me, oh, we got plenty of natural gas. I said in the presentation, I'm like, then how do you explain this? And they go, I can't. Because you can't. You can't discount my argument unless you discount the assumptions I've made. But every assumption I made is the most generous assumption. I underestimate usage, I overestimate supply. It's like saying, let's say for a minute, your car's gas tank is 1 gallon in size and it gets 5,000 miles to the gallon. That's an underestimate and an overestimate, yes. But even using ridiculous figures like that, I still can't make it go past 50 years. So that makes me nervous. Not so much for me, I'll be dead. Or crippled, you know, who knows when I'm going to be 90, I'll be crippled up. Hey, you damn kids. But my son, right? My son, who will not be in 50 years. He'll be close to retirement, I guess. Or your guys' kids. You guys! Right? I mean, this is what we have to deal with. You know how cold it gets here in the winter? Good Lord. No natural gas, which I think is how a lot of the houses around here are heated, yes? Yeah. And I was, say that again?
It's
A lot of
electric.
electricity.
A lot
Oh, a lot of
of
electricity. But what powers electricity? Well, Bonneville here, actually. Actually, I answered my own question. In Oregon, a lot of it's Bonneville. Quite a bit. Coal, clean coal. Yes, don't get me started on that. Clean coal. But Bonneville does power quite a bit. Every energy source has issues, correct?
Yes.
Every single energy source. Let's talk about it. Petroleum, issue.
Pollution.
Pollution's a big one. And that's going to be for almost all of them. Pollution, getting it. What's one big problem with supply dwindles? We've already gotten to eat. You know where the first crude oil was discovered in the world? Guess. And it was just bubbling underground like Beverly Hillbillies. Guess.
1840.
No, guess where?
Alaska.
Oh.
Not Alaska. Say that again.
Oh,
Not California.
Texas.
Not Texas.
Russia.
Not Russia.
Yellowstone.
Not Yellowstone. Good. These are all good guesses. You ever heard of the Quaker State oil? Maybe you haven't. Quaker State, the brand. What's the Quaker State? You guys are West Coasters. It's so cute. Pennsylvania. We're all the little Quakers in hats. Quakers, Quaker State, Pennsylvania, central Pennsylvania, walking along. What the hell did I just step in? You just stepped in the future of energy. It was bubbling up. And they sucked it essentially dry very, very quickly because they got the most easy oil. You've heard of the OPEC countries, Saudi Arabia, Arab countries. They have the easiest oil to get right now. And you've often heard about when gas prices skyrocket, oh, we should stop the importing. Precious little of our oil actually comes from those areas. I think it's less than 40%, maybe even less than 30%. Kelly, my numbers somewhat correct? Yeah, most of our oil comes from like Canada or like Venezuela. You know, if you go down to like Aruba and you look at the big refineries on Aruba, you know, you go across the Atlantic, there's a little channel right there 20 miles to, I think it's, I want to say Venezuela, I could be out in the wrong country. It's right next to Aruba. But gas is like 60 cents a gallon there because they have a buttload of it and they can refine it right there. I mean, that's, most of our oil doesn't come from little Saudi Arabian countries. Don't get pissed at the sheiks for driving our prices up. It's the price controls. What's that?
And why did the gas prices go up so high whenever there's any kind of...
Damn good. Well, because they can. Because we keep buying it. Why is diesel more expensive than regular unleaded? Can anybody answer that one for me?
Yeah,
Smells worse.
Shh, not anymore it doesn't.
It's higher in octane, isn't it?
I don't know. But what is it costing more? I don't think, you know, I don't know. That's a damn good question. I don't know the chemical makeup of it. It's easier to make diesel. If you look at the refinement of gasoline, I usually see it like a tower. You put crude in the bottom, and at the top comes out like rocket fuel or like 101 octane, whatever that super expensive stuff at the pump is. Diesel comes out at the bottom before even regular unleaded. So which makes you think, since you have to work less to get it, it should be cheaper, right? And guess what? In the rest of the world, it is cheaper, except in America. So why is it not cheaper in America?
Gas mileage when you use diesel.
Well, you get, well, that's almost a no-brainer is why we should all be driving diesels. You get much better gas mileage with diesel. No. It's not. It's more expensive because of subsidies. Because the government subsidizes unleaded gasoline and doesn't subsidize diesel like Europe does. Everybody should be driving diesel cars for the most part. They're clean. They used to be very, very dirty and very, very stinky and very, very smelly. We have a 2005 diesel Jeep Liberty. We bought it to run biodiesel off of. You can around. You can actually buy biodiesel. It's about $4 a gallon, which people are going to go, oh my God, $4 a gallon. But I have to tell you that even at the worst mileage, it gets 32 miles a gallon. At the worst. So I guarantee your guys' cars, for the most part, aren't getting 32 miles a gallon. You're probably not getting double, even half of that, I would imagine, in some of your cars. But the gas doesn't cost twice as much, right? So if my gas costs $4 a gallon, even like $4.50 a gallon, and your gas costs about $3.50, there's a ratio between those, yes? There's a ratio between $4.50 and $3.75, whatever I just said. I guarantee your mileage isn't in that same ratio, which is why we should be driving diesels. The only reason diesel gas would be not worth it is if it costs like $10 a gallon, which it hasn't yet, and it won't until I'm 90, Max is 60, and there's precious little gas left, and supply and demand kicks in, right? Supply and demand kicks in, and then we have this issue with, oh my God, we now have to struggle for these little tiny amounts of gas that are left, and we will have to pay, you know, exponentially higher rates for things. So it's better to head it off in the past now. And this is what we talk about in this forestry class. How many of you guys live in houses in Bend or Central Oregon that have southern exposures that allow the sunlight to warm your house in the winter? A couple of you. Couple of you. Very good! Yes. If you don't have that, it's called passive solar design. It blows my mind that it isn't code in this town. For the 300 sunny days that we get a year here. Sunny right now. Count it. Check. Right now, if we had a southern exposure on this building with nice windows that were letting the sun in, we'd be heating for free. That thing wouldn't be running. We'd be pumping power up here. We'd be heating for free. My energy bill for heating in the winter is 25% the Bend average for a similarly sized house. That means for every dollar you pay, I pay a quarter. That adds up really quickly. Really, really quickly. I should say it adds down really quickly, doesn't it?
Yeah.
It adds down really quickly. And that's free. The sun is doing it. Here's an interesting statistic. I was going to put it on your project, but I ran out of time and space. Every hour on this planet, enough sunlight energy hits the Earth to power all the Earth's energy needs for 1 year. In 1 hour. Now, the problem is a lot of that hits the ocean. Right? How much of the Earth is water? 2/3. So, 2/3 of the ocean is water, so you have to throw that out, unless you want to float solar panels, which the cost of doing that would be prohibitive, right? right? But Madras, I believe Madras' campus has a huge solar farm. Is that right? Or is it being built? Am I right or am I wrong about this? Or is it Redmond? One of those two campuses, maybe it's Redmond, they're building a big old solar farm up there. Hell yeah! You got a big blank area of desert. Throw some solar panels on it. What the hell? How many of you guys have solar panels on your house? Anybody have solar panels? They're expensive. They can be expensive. At least the upfront cost is expensive. But they pay for themselves. Especially when the government actually does subsidize those. They used to, a lot more than they do now. But you can put solar hot water. Anybody make a solar hot water for their garden? It's extraordinarily easy to do this. You take a big 4x8 sheet of plywood, go to Lowe's, go to the hardware store, buy that 5/8 inch irrigation pipe, right? Coil it up inside, staple it down so it's coiled up, right? Run it out, put a small solar powered pump in the line so that it moves the water through it, fill it with water, and just stick that thing facing south. It heats up, the sun hits it. You ever sat in the sun on a cold winter day and just gotten warm to the point you take your shirt off because you're warm? That's passive solar. Put that panel facing south, heats the water up, pump that small solar pump pumps the water through, you can heat your vegetable garden. That's how my house is heated when it needs heat. I use it's radiant floor heat. You bury radiators in the floor, essentially, which is just tubes running through your floor. Heats up the entire, it's nice and even. Oh yeah! And it rises evenly through. It's extraordinarily efficient. We're gonna have to deal with this. We have to deal with this, because if we don't, we're gonna get caught with our pants down in 50 years to 100 years. Because that's just natural gas I'm talking about being gone in 50. We still have petroleum, we still have nuclear, which is always frowned upon, but it's one of the cleanest sources, honestly. Just getting rid of it is the problem, which is a problem, because right now, when they get rid of nuclear rods, where do they put it?
In the Columbia River.
Utah. Oh, they went to Columbia too? I heard Columbia River, oh my God.
It's leaking at Hanford.
Oh, it's leaking, oh. Well, that's unintentional disposal. Yeah. Jesus, I didn't know that. No, there's this area of Nevada and Utah that it's surprisingly, quote unquote, right near an Indian reservation. And they tend to just dump. The tribe is called the Goshutes. That's the tribe of Native Americans that they're being buried right next to. It's appalling when you see how Native Americans are treated in this country, and then that's just like, oh, and by the way, we're going to bury nuclear waste right next to your reservation too.
That's cool.
Is that cool?
The real life pet cemetery.
Yeah, exactly. Essentially, yeah. That's look, the corpses. We have real zombies now. Yeah, Ryan.
The upside is that they'll be the first Native American tribe with superpowers.
Well, that's true. It's hard to laugh because it's makes people to cry. But anyway, and then there's water rights. There's a whole different thing to talk about. But anyway, how the hell are we talking about that? Oh, this is the problem of dimensional analysis. My God, that was 20 minutes ago. So yes, I do believe that was a tricky problem, but breaking it down step by step, at least, drives home the point of, I mean, how many of you were even guessing around 25, 28 miles for the size of that thing?
No.
Isn't it amazing? But what's amazing is you get lost in the math, right? It's so easy to get lost in that math, like 10 to the negative 7. Oh God, how many zeros is that? And then you make you change it to feet, because I'm a bastard. 3.28 times 10 to the negative 10th. I could just look at that recently. And it's like, what the hell is that even? Well, what that is, it's how thin that puddle is. Yeah. Anyway, so that was that. Other than that, was the project okay?
Yes.
Using Google okay to get the results you guys needed to? Google was okay? Good. Quizzes, quadratic regression. Anybody try those? Okay, you didn't have to. Golden ratioing? Is that okay? A little fun, a little artistic stuff mixed in with the math stuff, which I thought was kind of fun. Yeah. Good stuff. I could actually, I've considered maybe making a whole week on just the golden ratio. That'd be kind of fun. Would that be something that you, and not now, because, no, frankly, no. Who would like maybe a deeper look at the golden ratio in this class? See, that's what I'm thinking maybe. It's kind of fun.
It's everywhere. It's so cool.
It is, and that's what's interesting. We were having this discussion earlier about the most, what did you say here? You said that a beautiful face isn't that proportion. Right. I said it depends on how you define beauty.
Right.
But it's interesting how many places you can find it. Like, pull your wallet out and look at your credit cards. Look at your driver's license. Those are all roughly in that ratio. If you measure the long side with the short side and divide it, you're going to get about 1.6.
I think I remember seeing somewhere that the most, according to all people, beautiful faces are the ones that are the most...
Follow that most congruent with the, yeah.
Right? Like
yeah. Sure. That's fine. I don't find her attractive at all. But that's why I have to ask about what is beautiful.
Right.
Yeah, maybe it's a modal beauty, like we vote for them the most.
Right.
Yeah, absolutely.
Like that.
Then you can envision that mask from Scream. That's not very beautiful. So, interesting, yeah. Music. It even shows up in music. You got any musicians? I'm a drummer, but I barely qualify. The major sixth interval. The major sixth interval is the closest to the minor, or to the golden ratio. And it's considered very, very, it's actually a beautiful, major sixth. If you're in the key of C, it'll be C to E. C to E is a major sixth. So apparently that sonically, frequency-wise, closely resembles the golden ratio, and it's supposed to have, at the NBC theme song, boom, 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 the first two notes. I'm sorry about that. That was terrible. But those first two notes are a major sixth. I'm trying to think of a pop song that has it. I don't know pop music, so that's not going to help. Georgia Satellites, Keep Your Hands to Yourself. Old 80s song. I'll play it break. We'll hear it break. But anyway. But it is interesting how ubiquitous it is. How ubiquitous it is.
I like it.
Anybody do linear, the quadratic regression with the cancer rates? Sorry about the morbid data, but I just found it like, oh, look at that, it's a parabola. Let's talk about it. Good, interesting. A bit of annoyance with the units. But again, it's all about unit analysis, wasn't it? That quiz, the project, was all about dealing with the units. And that's something that I think we suck at as Americans. And I think a lot of it is because so much of it is done for us, and we don't think to stop. And I'm reminded comically of the movie This Is Spinal Tap, where, who's seen it? This is Spinal Tap, a few of you. The scene where he hires the lady to build Stonehenge, and he writes down inches instead of feet, and doesn't think twice about it. Like, it's a joke, but it happens all the time. I mean, NASA, how much money did NASA lose when they buried the Mars lander? Because somebody forgot to change feet to meters. Remember that? I don't know if you remember that or not. Maybe you don't remember that. Your tax dollars paid for it. So they buried, remember it, Ian?
No, the Hubble telescope didn't work.
Oh, because the lens was out of focus.
Yeah.
Because but what's amazing about that, it was off by like 1,000th of an inch. But that's enough precision to make it unfocused. How far out was it when they discovered that? Was it on like Saturn or something?
Yeah.
Unbelievable. But yeah, the Mars lander, the first Mars lander buried on Mars. Because they said, yeah, just bring it in 4 feet. What they meant was 4 meters. And they came in as though it were 4 feet, but it was actually coming in at 4 meters an hour versus 4 feet an hour or something like that. Well, that's a big difference. You know, there's like 3+ feet in a meter. And so we laugh, but your tax dollars pay for that. And its successor that they got the math right on. So, I mean, this is the kind of thing. It's all that project. It's all that project. So it's one of those, it's not much math, no? I mean, I think the hardest math, you took a square root at some point on that. Yes, a square root. And that was the hardest math that was in that project, right? Other than just dealing with scientific notation, which I know you guys hate. Chad, what's up?
Oh, I was just going to say, how do the NASA mathematicians
Brother,
mess up that?
I don't know. I don't know. Especially because when I watched Apollo 13, and I'm watching these dudes do these slide rule calculations to get these guys home with a faulty lem, I'm like, my God, that's like magic math.
4 feet, 12 feet.
Yeah, it's a big difference. But if you're working quickly, which I don't think they should be doing when you're spending billions of taxpayer dollars, but whatever. So anyway, extreme cases, but nonetheless, it also deals with you guys on a daily basis, making sure that you can heat your house properly, making sure you're not overspending for your bills. It permeates. So, and hopefully I gave you some interesting, pseudo-interesting examples. Those of you that haven't hit the 32nd birthday yet, I challenge you to celebrate your billionth second, which is way better than any birthday you're ever going to have. You only get one of those, right? You get a birthday every year. And birthdays are stupid too. You should celebrate your conception. Your conception is the interesting thing. Yes?
Not even actually, like if you think about it, the day that you're born and the day that it's kind of throw them off like for doctor's appointments, because when your baby's actually 30 days, they're like, it gets calculated, a day ends up coming off.
Well, my point is I don't even care when you're born. It's when you were conceived. The miracle of conception is worth celebrating.
Yeah.
Birthday is like whatever. It's like 30, it's like this fictitious number that we use afterwards. But celebrate your billionth if you can.
You're right.
If you haven't hit it yet. If you call home, find out the time you were born on the day you were born. Factor in leap years. Remember the 2000 was not a leap year. That was a weird one. Right? And then give yourself plus or minus 60 seconds around. They have like a little 2-minute party. I did. It's fun. And it's interesting. I go back to tell you guys about how we celebrated Max's millionth second, but we were sleeping during his 1000th second. And we'll celebrate his billionth when we get to it. Remember what the 1000th second was? It was minutes after he was born. We passed out. We all passed out, including he was exhausted too. The millionth second, I think, was it like 7 days in? I can't. We did it in class together, I thought. Millionth second, we didn't do it in class together. Oh, we didn't do it in class together?
No.
Nope. Let's figure it out.